Okay, so we've got the particle on an inclined plane, initial speed of 80 metres per second. The line of projection makes an angle of 30 with the inclined plane, and the plane is inclined at an angle of theta to the horizon. You have to be careful with the wording of these questions. First off, we'll just draw in the horizontal plane. A good diagram will help you a lot with this as well. So we'll just put the incline here, and we know if this angle here is theta. Now, the object we're talking about gets projected at an angle of 30 degrees up the incline here. So that's 30 degrees there. Now, this particle will project, will go up and come down and hit the plane over here somewhere. Now, we're looking for this angle here. We're also told that this is 80 metres per second. That's the initial velocity there. With all these problems, the first thing you want to do is to write out ux, uy, vx, vy, probably ax, ay first before vx and vy, ax, ay, vx, vy, and then sx and sy. Then the first triangle you're dealing with for ux and uy, I'll just draw it again here. We've got the hypotenuse is 80, Vx is along the x, and that's 30 in there. It's too small. So if we have $80 is the hypotenuse, Vx is along here, or Ux is along there, Uy is there, and this angle is 30, and this is a right angle triangle. Notice that cos of 30 is equal to the adjacent over the hypotenuse, which is ux over 80, and sine of 30 is the opposite over it, so it's uy over 80. So ux is equal to 80 cos 30, and uy is 80 sine 30. Now 80 cos 30, if you put into your calculator, the cos of 30 I think is root 3 over 2. So it works out as 40 root 3. The sine of 30 degrees is just a half, so this works out to be 40. We might as well leave it in third form, because if you look back at the question, we're given something in third. The tan of the angle, we'll come to that in a second, is 2 over root 3. Now, the acceleration, we know that gravity always works directly down, like that. But we're interested in what component of gravity goes perpendicular to the plane, which would be G or AY, and what component of gravity goes parallel to the plane, A of X. So we know that's G. We know this angle here is theta. I did that previously just to show that this angle here will be equal to this angle here if this is perpendicular to the plane. So what you've got in this case, cos of 30 in this case will be equal to AY over G, which is the hypotenuse side across from the right angle, and the sine of 30 is equal to AX over G. So we know AX, multiply both sides by G, is G sine 30, or sine theta. That should be theta there, sorry about that. And that should be theta from the diagram, not 30. So AY is equal to G cos theta. Now we just need Vx, Vy, Sx and Sy. So if you remember, I'll just put these in red, the equations of motion, V is equal to U plus AT, and S is equal to UT plus a half AT squared. Now these are the same for these components, so we know Vx is equal to Ux plus AXT. Now I'm just going to correct this for a second. Because these are both decelerating accelerations, I'm going to give them a minus value. So I'll sub these in then, what we know these are. So Ux is equal to Vx will be equal to what Ux is, which is 40 root 3. minus g sine theta. Uy is equal to 40 minus g cos theta, and then sx and sy, so again ux is 40 root 3 minus 1/2 at squared, so it's 1/2 of ax is g sine theta, so it's 1/2 g sine theta. I just took the minus sign out there, t squared, so that should be a t there, it's ut minus 1/2 at squared. And similarly sy is 40t minus 1/2 g cos theta t squared. So once you get to this stage here, you've got the guts of the question done out. The special point over here, now I want to do another diagram just to show this, is that when this object strikes the ground, it's going to come in at an angle like that, let's say. I'm just going to put the plane in again. Plane is here. This is going to be its final velocity is there. Now this velocity will have two components. One component you could talk about being perpendicular to the plane, so that would be Vy, and one component will be parallel to the plane, which would be Vx. That's a right angle between them, it should be. Now, I'll just draw this back here. This here is our angle here, which we know that this angle, if we just call it m, it's given in the question that the tan of m is equal to 2 over root 3, or the tan inverse of the angle of 2 root 3 is equal to that. So the tan of this angle is equal to 2 over root 3. So we know that we've got this angle here and this angle here. Well, we'll come back to that in 2 seconds. I'll just pause it there.